Welcome to the Carson Dunlop Video Training Series. I'm Alan Carson. This is the 8th in the series of videotapes in the Carson Dunlop Home Study System. If you have enrolled in the full Home Study System, you should watch this tape before starting the exterior module. You should watch the tape again after completing the module. You may also want to watch sections of the tape as you complete the corresponding sections of the text. This program is designed to give you a home inspector's perspective on exterior systems. There are thousands of different situations you'll come across in the field. This video is just the tip of the iceberg. Let's have a look at what we're trying to accomplish in the videotape. Our goal is to help you identify the various systems and their components. We also want to help you recognize common problems with each system and their components. We will show you the types of things that we see in the field and help you better understand what you're looking at. Our discussion assumes that you have a basic understanding of exterior cladding systems, structures, garages, basement stairs, water control systems, and retaining walls. This tape is designed as a companion to the text in the home study system and should enhance the knowledge you develop as you go through the text. This tape should be useful to new inspectors, introducing them to many of the common problems we find. It's also an excellent review for experienced inspectors, providing exposure to systems that they may not see every day. Let's start with exterior cladding. We'll look first at brick, stone, and concrete block. This is solid masonry construction. You can see the header courses, which look like short bricks every 6 rows or courses. These bricks turned sideways tie the 2 withes of the wall together. This is what the other side of the wall looks like. In this case, the backup withe of masonry is 4-inch concrete block. The backup withe can be brick or cinder block, for example. Here again, we're looking at the back of a solid masonry wall with brick on the outside. We are in a garage here and can see concrete block on the left and cinder block on the right. We can see the ends of the header bricks. This is another solid masonry wall with brick on the exterior and cinder block as the backup withe. This is a semi-detached solid masonry home that is undergoing renovation. The yellow brick at the bottom is a foundation wall. You can see on the left side that it is 3 withes thick. Above the first floor, the exterior wall is 2 withes. The wood studs of the interior walls line up with the floor joists below. The wood frame wall was insulated for acoustic purposes between the 2 homes. This is a wood frame house with brick veneer. There are no header bricks, which is one of the clues that the house may be veneer. Above the sliding doors and first floor window, you can see small rope wicks that drain the wall cavity. Brick is porous and wind-driven rain will go through the brick. Water runs down the 1-inch cavity behind the brick and comes out through weep holes at the bottom or above doors or windows. Here's a wood frame brick veneer house that is having an addition put on. You can see that the brick has been removed at the corner of the original house and the new wood frame structure has been built. The new brick will be toothed in with the old. You can see clearly here that the brick is just a siding material. Here is brick veneer being added to a wood frame wall section that is being clad with a house wrap. You can see the corrugated steel ties that are used to hold the brick against the wall. We've talked about solid masonry and brick veneer walls. Can you tell which this is? This is a solid masonry wall, although not every brick is turned endwise in the header rows. The header courses are about every 7 rows. The pattern is very irregular here. This is a stone and stucco house with a cedar roof with a pitch so steep you could almost call it a wall. What's the cladding material on these semi-detached homes? This is sculpted concrete block. This is a stucco home, and here we get a rare look at the hollow clay tile that makes up the exterior masonry wall. The ribs on the tile allow stucco to be applied directly onto the clay without lath. This is hollow clay tile. It isn't typically used as an exterior siding material. The ribs are designed so stucco can be applied directly to the tile without the need for lath. In this case, it has been left as a finished siding material. You can see the top of the poured concrete foundation wall at the bottom of the picture. This picture has three different siding materials. We have concrete block that has been painted a blue-green, we have brick, and we have hollow clay tile. In this picture, we can see brick on the right and stone on the left. We have building paper above the stone, and we can see the steel lintel for the brick above the door. This is a strange situation because it's a new house that the builder had trouble selling. He's replacing the brick with a more expensive siding in order to attract buyers. The soffits and fascia have been removed. There is a brown aluminum gutter and a Spanish-style concrete tile roof on this home. This is a stone wall that has been painted. Leaking gutters resulted in damage to the stone in the center of the picture. The mortar has been repaired, but the stone has not been repainted. This is a synthetic stone wall material called bradstone. It's essentially a concrete block, but has a distinctively stone-like appearance. It's difficult to add brick siding to a home because brick is heavy. Foundation walls are made wide enough to support the brick if the original siding is masonry. In this case, brick has been added by resting it on a steel angle iron bolted through the concrete foundation wall. Here's a close-up of the brick veneer that has been added. Here's a closer look at the end of the angle iron and brick wall. We criticized the absence of weep holes in this situation and described the angle iron as vulnerable to corrosion as a result of the arrangement. Wind-driven rain that penetrates the brick may run down the back of the brick and be trapped at the steel angle. Brick veneer is heavy and usually supported on a foundation wall. Supporting the brick on a steel angle is an alternative. Supporting it on a 2x4 is not appropriate. This is a relatively new brick wall with a masonry chimney. The chimney is a little more than 5 feet wide up to the top of the first floor and then narrows to just less than 3 feet wide. This common arrangement indicates a fireplace at the first floor level. Once the chimney is above the fireplace, it typically narrows. The water on the face of the brick is moving out through the brick from the clay tile liner, which is being flooded with a hose from above. This proves that the brick is porous. In driving rain, water will move in through the brick and mortar. This is a concrete masonry unit made to look like stone. Because the unit is almost white, it's difficult to pick up the efflorescence near the top of the wall. The units on end along the top of the wall are called soldiers because they are standing in a row. The efflorescence is on the soldiers and the two courses below. Here's a good example of efflorescence on a brick wall. Bricks that are exposed to the weather on both sides, such as on this garden wall, are particularly prone to efflorescence. Here's a close-up of the efflorescence. This is efflorescence at the bottom of a masonry wall along a brick patio. Moisture wicked up into the brick dissolves salts in the brick and/or mortar. As the water moves to the surface of the brick and evaporates, the dissolved salts are left behind as crystals. That's what forms the efflorescence. This deterioration to the brick and mortar is a result of moisture being wicked up out of the soil. Here again we can see damaged brick and mortar. The cause of the damage in this case is a leaking gutter above. This is a close-up of a blonde brick that has been sandblasted. You can still see remnants of paint on the brick and the mortar. The mortar is in need of pointing. More significantly, the sandblasting has left a very rough surface that will allow a good deal of wetting because of the large surface area. This brick may be vulnerable to freeze-thaw damage now that it has been sandblasted. Most masonry experts recommend against sandblasting. Here's a good argument for not sandblasting brick. Before they started sandblasting, this entire brick wall had been painted. When they sandblasted, they uncovered some brick which had been replaced. The brick in the lower right-hand corner of the picture was replaced with a harder brick, probably as a result of downspout leakage damaging the brick. You can see the unpainted galvanized steel downspout on the right. It's fairly common for the corner of poured concrete foundations to be weak. Here we can see considerable honeycombing and voids in the top corner of the concrete foundation. The synthetic stone veneer is in place, although we can see gaps in the mortar at the junction between the veneer and the foundation. This is a vulnerable area. Here we have a roof meeting a sidewall. The roof flashing was simply caulked to the brick. This kind of failure is very common. The flashing should have been let into a mortar joint in the brick rather than caulked to the surface. There are some interesting stresses on the foundation wall as a result of this tree. This brick is spalling. The hard outer surface is being popped off by water trapped behind the surface and then freezing. Most bricks should be kept at least 6 inches above grade. This is an example of why that's important. You can see how the brick at grade level is spalling due to exposure to the moisture. Here's more of the same damage. We are inspecting this home shortly after a rain. You can see the brick on the left side of the picture is wet below the wood railing. Looking more closely, you can see the brick is spalled around and to the left of the downspout. This is a perfect example of how failure to control roof water runoff may result in brick damage. This brick is spalling because moisture trapped in the brick is freezing during cold weather. This concrete unit is made to look like stone. You can see the cracking that extends down from the end of the windowsill. The cracking follows the mortar joints because the bond between the mortar and the masonry unit is weaker than the masonry unit itself. It's common for cracks to appear around windows because these are weak points in the wall. Here's another example of a crack in the mortar, this time extending up from a door opening. This crack is again following the mortar joints. Good brickwork includes mortar that is slightly weaker than the brick. It's less expensive to repair mortar than to replace cracked bricks. None of the cracks that we have looked at so far are necessarily important from a structural standpoint. However, in none of the cases have we been able to get the whole picture. These could be part of a significant structural issue, but we don't have enough evidence to know for sure. Here we have a significant vertical crack that has been patched at least once and subsequently reopened. This is structure movement rather than a siding failure, indicating settlement of the addition on the right relative to the original house. Here's a significant crack in a solid masonry wall. The crack is significant because there's movement in more than one plane. We can also see that the crack has been patched and subsequently reopened. Cracks that are not patched are sometimes harder to see. Cracks that are covered with vines or shrubs are even more difficult to see. Can you spot the cracking in this brick veneer wall? Here's a close-up. You should be able to see the cracking in the lower half of the picture. Attaching large towers or antennas to brick walls can sometimes create interesting movement. Here the brick is being pulled away from the home. Look along the side of the window and at the soffit. Here's another example of brick pulling away from the house. This is another example of brick pulling away from the home. Look along the side of the window. So, do brick homes last forever? Not necessarily. Stone, on the other hand, lasts a very long time. At least that's true of the stone used in Stonehenge. We've had a look at brick, stone, and concrete block. Now let's get a look at some stucco. This is a conventional hard coat stucco application. Number 1 could be plywood or concrete block substrate. Number 2 is felt paper or sheathing paper overlaid with galvanized steel lath or mesh. Number 3 is the scratch coat of Portland cement-based stucco. Number 4 is the second or brown coat. Number 5 is the finish coat. This is a synthetic stucco treatment. Number 1 is a wire mesh that is embedded in number 2 in the adhesive base coat. The adhesive base coat bonds itself to the expanded polystyrene insulation. Number 3 and 4 are synthetic finish coats. You'll notice that there's no building paper in this assembly, and as a result there is no backup protection in case water gets through. Here's another synthetic stucco application. Number 1 is the expanded polystyrene insulation. Number 2 is the reinforcing glass fiber mesh. Number 3 is the adhesive base coat, which typically has some Portland cement. Number 4 is the synthetic finish coat. This is the first coat or scratch coat of stucco on a new home. You can see the wire lath through the stucco. Now we have the second coat or brown coat on the same house. This is the third coat or finish coat in place. There are many types of stucco walls. Stucco can be applied over masonry or wood frame walls. This is stucco over masonry. You can see a pilaster between the two windows that extends to the top of the first floor. The brick windowsills and wall thickness are clues that the wall is masonry. We confirmed it by tapping on the stucco. This house is stucco over masonry. In our experience, stucco applied over masonry performs better than stucco over wood frame. This is another stucco wall with a dramatic pattern pressed into the stucco. This one is over wood frame. The vulnerable details in this wall include the wood planks, especially the horizontal ones. The top edge and end grain of the boards usually rot first. Stucco should be kept roughly 8 inches above grade. This is what happens when you don't. Here's a more subtle example of the same thing. Here we've got stucco over concrete block, terminating at an asphalt driveway. No weep screed was used, and the stucco just dies out about an inch or two above the driveway. This installation is relatively new, but deterioration can be expected over time. Here's a similar situation along a driveway. In this case, you can see the wire lath extending below the finish coating. The wire lath is rusting, and the bottom edge of the stucco will soon show deterioration. We can already see rot at the bottom of the garage door frame and trim. This stucco has a decorative texture and decorative grooves. While these are not designed as control joints, cracks often develop in these grooves. Check these closely. Penetrations through stucco walls are vulnerable points. Here we have a drain at the bottom left, a clothes dryer vent in the top center, and a power vented water heater exhaust at the top right. This exterior hose bib is another penetration in a stucco wall system that can be a vulnerable spot. Here's another water heater vent penetrating a stucco wall. No attempt has been made to seal the pipe where it passes through the wall. This air conditioning disconnect switch again creates a weak spot in the stucco wall. You can see the electrical line going through the stucco wall below the switch, and the refrigerant lines below that penetrating the stucco. Here's a house that is solid masonry construction on the first floor. The large dormer on the second floor is wood frame with stucco cladding. If you look closely, you may see a flaw in the bottom of the stucco, just to the right of the downspout. Here's a closer look at it. Here's what we found when we started to tap on the stucco. The finish coat was not well bonded to the brown coat. In some cases, the brown coat was not well bonded to the scratch coat. You can see here how thin the finish coat is. Here's a fairly common crack in a stucco wall. Conventional stucco usually has building paper or house wrap behind. Synthetic stucco walls may not have any backup protection. If that's the case, this crack is a serious flaw in the wall. It needs to be sealed promptly to prevent damage to the sheathing and wall structure behind. It's easy to see that this stucco was applied over solid masonry. The stucco is failing as a result of movement of the foundation. In this case, the siding failure is a clue to a bigger problem rather than a concern in itself. Here's an obvious failure in a stucco wall. Again, the half-timbered look typical of Tudor-style homes creates a number of vulnerable areas where water can collect. This amazing picture shows that stucco over wood frame isn't strong enough to withstand earthquakes. Since this is Los Angeles, the exterior air barrier on the insulation is not a problem. In colder climates, this would be a recipe for condensation problems in the wall cavity. The next several pictures are of a 5-year-old stucco home. We declined to continue the inspection when the homeowner explained that the reason he had engaged us was to lodge a complaint against the builder because of problems he was having with his siding. Details like this window top made us nervous about what might be behind. Our inspector recommended invasive testing rather than a visual inspection. The discoloration on the window drip cap suggested water was accumulating here. The caulking on both the stucco and the window itself suggested somewhat desperate measures had been taken to control leakage. Here's another window detail that made us uncomfortable. This is another example of the same concern. Here we are at the intersection of 4 windows, and again the evidence of desperation caulking is unnerving. We also saw cracking in the field of the stucco with streaks below, suggesting water may have been running out of the cracks. The rusted end of this steel railing also made us suspect that there might be moisture penetration problems here. When some of the stucco was removed, we were glad we had not been conclusive. Here we are at the top of a window. We have plywood sheathing and what's left of the felt sheathing paper. You can see the clear polyethylene air vapor barrier, which was extended from the inside wall surface through the opening and wrapped around the outside of the window opening before the window was installed. You can see the beads of water on the polyethylene. You can see the rusted drip cap flashing. We had trouble understanding why the building paper disappeared behind the flashing at the top of the window. As more stucco was removed along the side of the window, more wetness and water damage was found. Here's another area where evidence of considerable water damage was observed. This house has vinyl siding on the upper part and stucco on the lower part. We are hoping the trim and flashing isn't complete around the doorway. You can see the raw wood above the door and the open joint along the side of the door. This stucco is in poor repair, especially near grade level where large chunks are missing. You can see the wood lath that was used on this house that was built in about 1880. If you see this kind of distress in a stucco wall, you're going to recommend re-siding. This vulnerable joint in a Tudor-style home tends to catch water. Water sitting in the V at the top of the picture and on the ledge along the top of the horizontal board allows moisture to be drawn into the end grain of the two top pieces of wood. Both of the top boards were badly rotted here. Here we've removed the boards covering the hardboard panels with a stucco-like finish. The boards were rotted and the hardboard is largely disintegrated. Here we've removed the hardboard panel type siding and the asphalt impregnated fiberboard sheathing. You can see damage to the bottom of the studs and sole plate. We are adjacent to a bathroom here. You can just make out the bathtub on the other side of the studs. This home was in a wet climate and we had two problems. Condensing interior moisture was trapped in the wall cavity, especially around the bathtub where there was no insulation or air vapor barrier behind the tub. On the exterior, rain was getting hung up on the wood members that were covering the joints in the hardboard siding. These patched holes in the stucco wall indicate that insulation has been blown into the wall cavity. We've had a look at some stucco systems. Now let's look at wood siding. This is new cedar shingle siding. This is cedar shingle siding which has not been painted. The discoloration on the bottom half of many of the shingles indicates where water typically accumulates and is held in the siding. The end grain of the shingles wicks moisture up. While we can't get a good look from here, the drip cap flashing above the half-round window is a vulnerable detail in this gable wall at the end of a gambrel roof. Some of the wood shingles are damaged and missing along the top and bottom course. The shingles have been stained and the variation in color is due to moisture. It had just stopped raining when we took this picture. This is board and batten wood siding. This is vertical redwood siding. The front and backs of each board are being stained before it is installed. This is a good approach, and the stain lasted 8 years before the siding had to be restained. This is asphalt impregnated fiberboard sheathing over a wood frame wall. We are getting ready to add the siding. What is the horizontal wood strapping for? If you guessed that we were going to have vertical siding on this building, you were right. Horizontal siding can be nailed to studs. Vertical siding can't be nailed to studs because many of the boards will be between studs. A heavy plywood sheathing can be used, but horizontal wood strapping is less expensive. The siding installers have to make sure that their nails hit the strapping. The strapping has to extend around the perimeter of the walls and around the door and window openings so that the ends of siding boards that meet these details can be securely nailed. We can see a poor detail at the lower right corner of this window. Water penetration behind the siding is easy to imagine. Below the window and in the bottom right part of the picture, you can see the round head siding nails. Sometimes the siding is also the wall structure and the interior finish. This log home is an example of that. Log homes are tricky because they expand and contract vertically more than wood stud walls. A gap has been left above this door to allow for movement of the wall without buckling the door. The gap is needed for structural reasons but should be more weather-tight. At the top of the picture you can see the bottom of the board and batten siding. Many consider the double nailing at the bottom of the battens a mistake for two reasons. The nails close to the edge of the boards may make the battens subject to splitting. Further, a single nail in the center of the batten could go between the two siding boards beneath. The siding boards would be pinned in place and allowed to expand and contract horizontally if the nails were centrally located in the batten. This is a somewhat controversial issue, and many siding installers feel that it is better to secure the boards as well as has been done here. We wouldn't recommend rearrangement of this situation, but would advise our clients to watch for splitting of the boards or the battens. Checking is very common with log or heavy timber construction. The checking in the log below the window is not a structural issue. It is a natural drying process of the wood. Here's another board and batten treatment where the battens and corner boards are solid wood, but the backup boards are plywood. The big mistake here is that the siding extends down to grade level. It should have stopped 8 inches above. Here we can see peeling paint on wood siding, just above a chimney shoulder. Paint failures like this usually indicate trapped water behind. The water may be getting hung up on the brick shoulder or may be getting in at the window above. While it's hard to see, there is also a large section of paint coming off near the bottom of the wall to the left of the chimney, just above the shrubs. You have to look closely at wood siding. Here we can see fresh paint and filler concealing some very rotten siding. What are the implications of wood-soil contact? Well, they're pretty obvious here. Incidentally, those of you in northern climates should be wondering why the polyethylene vapor barrier is on the cold side of the insulation. Exterior corners on wood siding details are vulnerable because wood end grains may be exposed. Cutting the wood on a bevel to create outside corners like this exposes a good deal of end grain. The adjacent downspout may be the source of moisture that's led to this rot. Sometimes the siding isn't in very good shape, but there are bigger issues to worry about. If you're not suspicious about the structure here, have another look. Here's another shot of the same building. Now are you suspicious of the structure? Complicated details are always a challenge, especially where different trades are involved. Here we have a flat roof meeting a wood shingle roof on the right and a wood frame wall on the left side. The transition between the flat roof and the wall is at a 45-degree angle over a 2-foot distance out from the wall. We have a modified bitumen flat roofing membrane extended partway up the wall. There is a metal counter flashing on the roof membrane. We have step flashings on the right side where the wood shingle roof meets the wall, and we have metal valley flashing where the wood shingle roof meets the flat roof. Ice and water shield has been applied to the left side of the valley flashing and extended over to and partway up the wall. Once this work is completed, you won't know how this system was flashed. Check carefully inside buildings below vulnerable details for evidence of water damage. Here's another vulnerable detail. The wood shingle roof is meeting a wall. You can see a metal counter flashing and some evidence of ice and water shield behind. We are hoping that house wrap or building paper will cover the plywood and extend down over the top of the metal counter flashing. The siding should then cover the sheathing paper and the top part of the counter flashing. This detail is further complicated by the unfortunate location of the electrical and refrigerant lines for the air conditioning penetrating the wall at this flashing. Is this a potential leakage area? Of course. Here we have board and batten siding that is too close to grade level. We were particularly concerned about the siding here when we noticed that the white fence on the left side of the picture was heavily infested with termites. Here the ends of the siding boards have been well caulked where they join a vertical wood member, but they missed caulking one of the boards. Here is what happens over time if the ends of the board are not well sealed. This siding, coming right down to grade, is vulnerable to rot. Paint is peeling off this wood siding, and at the bottom of the picture you can see that the wood behind the paint is wet. In this case, the problem was moisture exfiltration from inside the house. A combination of high interior humidity, a poor air vapor barrier, and siding with joints that had been tightly painted made it impossible to keep paint on this wall. Here's another example of paint being pushed off the wall by moisture behind. Sometimes paint failures are localized, such as we see here. As we look closer, we can see that the siding is in direct contact with the roof shingles. The siding should have been cut back 2 inches above the shingles. Moisture drawn into the boards through the end grain has pushed the paint off the wall surface. The wood siding on this home has gotten wet and swollen. The boards have buckled in a number of locations. Here's a close-up of the buckled siding. The moisture may be from a chimney flashing leak, a roof leak, ice damming, or high levels of interior moisture moving out through the wall and getting trapped behind the paint. Here, ice dams on the roof are damaging the siding and the wall structure behind. The wood siding on this house has weathered badly where it is exposed to the elements. This siding on the north side of the house does not show the same weathering. Believe it or not, this siding is on the same house, this time with a southern exposure. You can see the carpenter's awl easily penetrated the rotted wood in this log home. The alligatored paint on this siding and wood trim will probably have to be removed before repainting, dramatically increasing the cost of the next paint job. The rotted siding and column are the result of inadequate wood soil clearance. During the inspection, the siding appeared to be in good repair, and there was no evidence of carpenter ants. However, when the siding was removed, an extensive carpenter ant infestation was found. Now let's look at plywood, hardboard, and OSB siding. This is plywood siding around a window. We have asphalt shingle siding on either side of the plywood. Many of the asphalt shingle tabs are lifting off because the tabs were not sealed down. There is damage to the lumber filler piece on the right side of the window. You can see the failed caulking joint between the plywood siding and filler piece below the window on the right. Again, we have plywood siding, in this case above a brick wall. The siding terminates at a metal Z flashing along the bottom edge. A horizontal wood board acts as a separator between the brick and the plywood siding. The brick is wet in 2 areas. On the right side, it's because of a leak at the gutter downspout connection. On the left, there's a seam in the metal flashing at the top of the brick. There is a horizontal ledge here that collects water, which leaks through the flashing joint onto the brick below. The moisture is getting behind the brick as well as running down the front surface. We have a vertically grooved plywood siding on the left-hand building. On the right-hand building, we have plywood sheets overlaid with 1x2 battens to create a board and batten look. Metal Z-flashings have been used at horizontal joints. These flashings extend up behind the higher panel and down over the front of the panel below. Here's another plywood siding detail where the plywood has been cut back above the roof shingles. We would like to see a 2-inch clearance here. This is somewhat less than the ideal 2 inches, but this one has been performing well. Here we have another plywood siding detail with a batten type overlay. You can see the horizontal joints do not have the metal Z flashing. As a result, we can see delamination of the plywood at the horizontal joints. This is a result of moisture getting in at the panel edges. The paint has blistered on this plywood soffit as a result of excess attic humidity. The next shots are of hardboard siding. This picture looks very much like wood siding, although if you look closely you will see that the grain and knot patterns are too repetitive and uniform to be natural lumber. If you look closely, you can use the pattern of nail heads to locate the studs in the wall. While it doesn't show up well in this picture, there is some deterioration of the siding around nail heads. Here we can see evidence of the nail heads penetrating the surface of the siding. This is not a desirable situation because water may get into the siding at the nail hole and the holding strength of the nail is greatly reduced. Deterioration around nail heads is not the only problem with this wall, as you can see here. You can see where the wall tends to get wet. The siding is badly deteriorated in these areas. Here's a close-up showing more deterioration of the hardboard siding. This is a closer view. Here's a close-up. Obviously this siding had to be replaced. This hardboard siding is buckling because it has been nailed on too tightly. This siding expands and contracts considerably along the length of the boards. Unless movement is allowed for, this can be the result. Now we'll look at some metal and vinyl siding. This is a vinyl siding installation. You can see the joints in the siding clearly. The joints should be well staggered so that they are less visible. Here we can see one of the pieces of siding has come loose near the bottom. This is damaged vinyl siding. This kind of break is the result of an impact. This aluminum siding was installed with a fiberboard backer to add rigidity. The sheathing is asphalt-impregnated fiberboard. The building has been destroyed by fire and the aluminum siding has been partly ripped off by firefighters. Here's a solid masonry home that has been covered with aluminum siding. The home is now being renovated and the siding is being removed. This home was eventually stuccoed. Here we have a door with no drip cap flashing. Leakage around the door is a strong possibility. This weak detailing at the top corner of a window is likely to result in leakage. Here you can see the nail slots in the top piece of siding. The nails should be centered in the slots and should not be driven home. The siding should hang on the nails and be allowed to expand and contract without buckling. Although metal and vinyl siding is not susceptible to moisture damage, the backup material is. This siding should have stopped about 8 inches above grade. Here we have an exhaust and combustion air intake for a gas fireplace coming out through the vinyl siding. If this arrangement is not well made, the siding can deform or melt with the heat. Here a missing end cap on aluminum siding is allowing water into the building. This unfortunate design has a roof valley ending against a wall. The bottom sections of siding have been removed and replaced with a membrane in an attempt to control the leakage. Now we'll look at fiber cement siding. This is horizontal board fiber cement siding. The siding has a wood grain finish. The vinyl siding clips protect the vertical seams. In our opinion, this is a better approach than using caulking. Many installations would not have these seams lined up vertically, so they wouldn't be so noticeable. This is another way to handle vertical butt joints. This would be typical where panel type siding rather than board siding is used. Again, these joints could be caulked, but this is a better approach. This is a vinyl inside corner detail. This trim piece is often wood. The preformed vinyl detail has the advantage of flanges that extend out beyond the siding at either side. A wood post would not offer this protection. Again, you can see the wood grain pattern in this fiber cement siding. Here we have a vinyl starter strip visible at the bottom of the siding. This puts all the siding at the same angle, providing a uniform look and parallel contact at the top of the first piece where the second board covers it. This fiber cement board has a wood grain. It's easy to mistake this for wood. You need to look closely and tap on the siding. Fiber cement siding boards are typically 5/16 of an inch thick, much thinner than wood siding. The board width is often 6.5, 7.5, or 9.5 inches. Here's another wood finish on a fiber cement siding board. This fiber cement panel is made to look like stucco. Again, unless you see the edge of the panel, it may be hard to identify. One clue may be the regular joints. This system comes in 4x8 panels. Conventional or synthetic stucco does not need joints every 4 or 8 feet. These panels are thin, about 5/16 of an inch thick. Here's another 4 foot by 8 foot fiber cement panel designed to look like vertical wood siding. This pattern is similar to one used on plywood siding. This fiber cement siding is in good shape, although it's very old. This is older fiber cement siding. This is very good quality siding material. These large panels may break under impact because they are brittle, but stand up well to normal use. The entire building has been moved by an earthquake, and you can see how the siding has either broken or fallen away in some areas. Here's another failure involving fiber cement siding. Again, of course, the siding is not the issue here. The building has been moved off its foundation. The siding was in good shape, even though the clearance above ground level was less than the recommended 6 inches. Now we'll look at some asphalt shingle siding and insul brick. This townhome has brick siding on the first floor and asphalt shingle siding on the second. A new window was being installed in a wall with asphalt shingle siding. It's not unusual for the shingle tabs to be lifting slightly, as we can see here. The tabs should be sealed down with roofing cement. On vertical applications, the self-sealing strips on shingles will not hold the tabs in place. On a siding application, 6 nails per shingle are recommended rather than the 4 that are commonly used for roofing. Asphalt shingle siding is not as durable as masonry siding, for example. This damage was caused by a raccoon. Some of the roll roofing has also been torn away. In the foreground, you can see relatively new asphalt shingles laid partway up the roof over old asphalt shingles. The top row of the new shingles has been tarred into the old shingles. Obviously, this is low-quality work. This is an asphalt-impregnated fiberboard siding material, sometimes called insul brick. The fiberboard is bonded to a large asphalt shingle embossed with a brick pattern. Insul brick is a brand name that has become generic, at least in our market area. There is, of course, very little insulating value to this siding. It has been partially removed here during a renovation project. but this siding material is probably 40 to 50 years old. It is surprisingly durable, although it is subject to mechanical damage. There are both side laps and overlaps at the panel edges. Here's another view of the same wall. Here we can see deteriorated insul brick. Near the bottom of the picture, you can see the overlap that we discussed. This panel was torn and water got in behind the panel, causing the damage we see here. You can see some loss of the granular material on the surface. This is another wall sided with insul brick. Few homes were sided originally with insul brick. It was usually a re-siding material. This is the same type of siding, although made by a different manufacturer. This one is imitating stone. Although the siding is not laying flat against the wall, it was watertight at the time of the inspection. You may have noticed the lack of a drip cap at the top of the window. An insul brick type siding is being removed in preparation for new siding application. Let's turn our attention to soffits and fascia. This is an aluminum soffit with some perforated soffit panels providing attic ventilation. The fascia and gutters are also aluminum. Every aluminum soffit piece is perforated to provide ventilation here. The decorative wood brackets and small section of vertical aluminum siding on the top part of the wall are unusual. Here we have a stucco soffit with an obvious repair. Here's another stucco soffit that has had some moisture penetration. This stucco soffit has been partly replaced by plywood. You can see the water damage to the right of the plywood. A continuous aluminum vent strip has been provided through the middle of the soffit. Part of it is missing in the area of the water damage. The pipe penetrating the soffit is a downspout from a flat roof above. The icicle draws your eye to the soffit damage. This wood plank soffit is badly rotted. We can't see the soffit here, but we can see the ice dams in front of and behind the fascia. We can anticipate damage to the fascia and soffit. Here's another ice damming problem where icicles are hanging off the gutters and fascia. The plywood soffits won't stand up to much of this. Here we have considerable ice damming, and you can see that the roofing material and sheathing is severely damaged. This home has integral gutters. Leakage through the gutters in the area of the downspout is damaging the trim at the eaves and discoloring the brick below. This fascia board rotted because water ran over the edge of this flat roof over a long period of time. The drain pipe on the left side of the picture was clogged. Had the drain worked properly, the water would not have run over the roof edge and the fascia would not have rotted. Now we'll look at windows, trim, flashings, and caulking. This is a vinyl casement window being installed in a wood frame wall. You can see the polyethylene air vapor barrier that has been put in around the window frame. It will join to the interior air vapor barrier, preventing moisture from getting into the wall from inside and from around the window frame. This is the outside of the window we looked at in the last picture. This is another casement window. You can see the wood shims and polyethylene air vapor barrier. This casement window has just been installed. Again, you can see the wood shims and the black plastic air vapor barrier. This old building is getting new windows and siding. The size of the sheathing boards tell you this must be an older building. The siding that is being removed is insul brick. There is building paper behind the insul brick. You can see the nailing flanges on the window. It's hard to see, but there's an integral drip cap flashing at the top of the window. This is a wood window sill in a stucco wall. The groove cut along the bottom of the sill is a capillary break. In a wind-driven rain, there is a good deal of water that runs down the window and over the sill. This groove makes the water collect and drip off the underside of the sill. We don't want the water to run back to the joint between the wood sill and the stucco. Here's a concrete sill with the same kind of capillary break cut into the bottom. This concrete sectional sill is vulnerable to water penetration into the wall where the mortar joints have deteriorated. Water has penetrated this concrete sill and the sill is failing. There is probably steel reinforcing in the concrete that is expanding as it rusts, causing this cracking pattern. This is a two-story bay window assembly that looks pretty good from here. However, the wood boards in the section between the first and second floor were seriously rotted. The fresh paint covered the rot. Here we can see paint and caulking deterioration on a windowsill. This is a natural weathering effect. The poor slope on the wood sill tends to hold water on the sill, leading to faster deterioration of the wood and greater potential for water penetration into the wall. Here's another example of rotted wood around a window that was not visible because of fresh paint. We had to probe to find the significantly rotted wood. The bottom corners of windows are typically weak spots. This is a close-up of the damage we looked at in the last picture. Here we've removed some of the drywall and interior trim from the window. We can see evidence of leakage below the window. There is deteriorated wood along the outside of the window at the bottom. While it's hard to see, this sill detail was very poor and water was getting into the wall below. This is an unusual view of a wood frame masonry veneer wall with no windowsill. A concrete sill will be provided here. You can see that the window itself does not extend out beyond the face of the wall. We are going to rely on the connection between the bottom of the window and the concrete sill to direct water away from the wall. Here's a windowsill that looks good because it's just been painted. However, we realized as soon as we touched the sill that it was weak. A knife easily goes through the badly rotted wood. We can see deteriorated wood around and below a window. Here we have vertical wood siding surrounding the window. These vinyl windows have slots in the bottom to allow moisture to escape. The inappropriate slope of the windowsill does not encourage water to run off. Caulking between the siding and window has obviously been neglected. Here we can see movement of the entire window relative to the wall. Here we have a window at a driveway. We would probe for rot here, since we are so close to grade level. This window is very close to grade. You can see the deterioration along the bottom. Look at the steel lintel above the window. You can see the gap between the window and the lintel, which was never properly sealed. This lintel is rusting, and it's difficult to tell how much of its strength has been lost. We recommended invasive work to further evaluate and replace the lintel if necessary. You can see the movement between the top of the window and the steel lintel. This is a structural problem. Here again you can see significant movement of the building relative to the windows. Multiple layers of caulking often indicate problems. Glass block window openings are often a source of leakage problems, especially when the caulking is missing or ineffective, as we see here. The next few shots are intended to help keep your exterior cladding inspections in focus. Here we have a dramatic structural failure. The siding failures are only one of the clues. This again is the 1994 Los Angeles earthquake. These red vertical steel channels are attached to cables that go through the building and attached to another set of channels on the other side of the building. This small apartment complex settled dramatically because it had been built on a filled riverbed. The steel superstructure stabilized the building, at least in the short term. Here we have wood siding with deteriorated parging on the foundation wall below. We are encouraged to see that the siding stops several inches above grade, but the deteriorated parging catches our eye. This kind of thick parging is often applied to a deteriorated foundation. This brick wall has moved considerably. The glass slides on either side of the crack are used to monitor the movement. There has been dramatic movement in this wall, as you can see. The sloppy mortar repairs exaggerate the crack locations. There was more than one generation of patch, suggesting that the movement was progressive. Here's an unusual brick failure. Why would this brick wall be deteriorating beside and above the windows? The answer lies in what's behind the wall. Although this wall is rectangular, the roof behind the wall is a low-pitched gable roof. The brick deterioration follows the roof line closely. Water and snow accumulating on the roof have penetrated the brick at the roof wall intersection. The water has moved through the brick from back to front and peeled the paint off. In cold weather, the water in the brick freezes and spalls the brick. Do you see any vulnerable areas here? We wonder how water will get out of the valley created between the two roofs that form a V in the center of the picture. We were also surprised that the decorative wood brackets below the cedar siding project out beyond the siding, creating horizontal ledges at the top of each bracket. Balconies are always vulnerable, especially if they don't drain readily. Do you know what the wood spikes are called at the top of the gable roofs on the left side? These are finials. Did you notice the fire separation wall that projects beyond the wood siding, just to the left of the center of the picture? It's clad in aluminum and extends beyond the roof, as well as out beyond the wall surfaces. Almost invisible behind the shrubs is some brick siding. This building has brick, stucco, and wood shingle siding, all on the same elevation. Vines obstruct your inspection. You should describe them as a limitation. We recommend that vines be kept away from wood doors and windows and gutters and downspouts. Vines on homes may be attractive, but when they threaten to make the house disappear, things have gotten out of hand. Vines should be kept away from wood around doors, windows, and eaves, for example. Vines should not engulf gutters and downspouts. This is a strange-looking wall repair. The pattern is too regular to represent repointing work. These are application holes for urea formaldehyde foam insulation. The insulation was never designed to be injected into solid masonry walls like this. The space between the two withes of the masonry wall is less than 1 inch wide. Adding insulation here did not make sense from an energy efficiency standpoint, even if the material were not controversial. Here we have a solid masonry house with a poured concrete foundation. The foundation wall has been parged with a Portland cement parging. Moisture inside the foundation has pushed the parging off the wall. The low-quality concrete foundation was in distress behind this superficial repair. This old stucco home in Europe shows some interesting roof movement. This modular construction may be hard to identify once the home is complete. From the home inspector's perspective, it doesn't matter whether the home is modular. Our inspection is performance-based, and as long as everything does its job, it doesn't matter how it was put together. In our experience, the factory conditions in modular construction often lead to very good quality detailing. You can't always judge a book by its cover, but when the exterior of the house looks like this, odds are it's going to be a long inspection. Planters against building walls are a common cause of rot and insect damage. Significant rot damage was revealed when this compost pile was moved away from the building. Stacking firewood against a house wall is not a great idea. The possibility of insect infestation and rot are very real. This is not a common use for logs. This wall is made of logs cut short and stacked with chinking, leaving the end grain of wood exposed to the weather. The significant expansion and contraction and susceptibility to rot make this a vulnerable wall assembly. Now we'll look at exterior structures including steps and landings, handrails, columns, porch roofs, beams, joists, floors, and skirting. This is a concrete block porch with poured concrete steps and a poured concrete landing. The railings are painted steel. The sides of the porch are stuccoed. These two patio slabs have been laid directly on the ground with a precast concrete step on top. As you can see, the patio slabs have settled unevenly and the step now wobbles on the slabs. Further, the step is about 7 inches tall. However, the distance from the top of the step up to the door sill is about 10 inches as a result of this settlement. A maximum rise of roughly 8 inches is recommended. The stairs should also have a uniform rise. A galvanized steel window well has been provided around the basement window to the right of the door. The steel window frame is rusted because of the debris that has collected in the window well and held water against the window frame. These deteriorated concrete steps are a trip hazard. Here's another view of the same steps from the bottom. These brick steps have settled and now pose a trip hazard. The 6-inch by 6-inch wood framing for the front porch is rotting. The door trim is also rotting at the bottom. The siding is relatively new, but unfortunately extends all the way down to grade level. It may be expected to rot soon as well. 6 by 6 landscaping timbers have been used to create retaining walls and steps. The life expectancy of these systems is relatively short, even with the use of pressure-treated lumber. The debris on these steps can make them difficult to see, posing a trip hazard. This is more of an issue where the steps are irregularly spaced, as is common in landscaping work. Here we have a raised wood deck supported on concrete tube-type piers. The steps and railing are supported on a wood platform directly in the soil. Settlement may be expected over the next few years. The stair stringers have only their toes bearing on the wood platform on the bottom. This is not a good arrangement. We suspect that these steps were constructed before the final grade was determined, and the box and bottom step were fabricated sometime after the main set of steps. The old porch with gray wood steps on the right has no railing. The green wood column rests on a masonry pillar that has settled. The bottom of the column is starting to kick out to the left. On the house to the left, an open front porch has been enclosed. Aluminum siding has been used to clad the pillars and create skirting that goes down to a grade level. The door on the enclosure opens out over the steps without a landing. Someone at the door may be knocked off the steps when the door is opened. Here we have French doors opening out onto a deck. This arrangement is a good one, with a 6-inch step up from the deck to the door threshold. This helps prevent leakage through the door threshold, especially where snow accumulates on the deck. These concrete steps have worn badly and are a trip hazard. These concrete steps have dropped almost 3 inches and now pose a trip hazard. These exterior steps have been built in 2 stages. The risers are not uniform and there's no railing on the upper section. These steps are not safe. This is a close-up of the steps we looked at in the last picture. The steps are pulling away from the wall. Wood soil contact and a poorly cut stair stringer are concerns here. Inspecting the exterior steps and landing on this home is a big job. It may not be worth looking at all these steps. The first support post we checked looked like this. The second post looked like this. The third one didn't look any better. Temporary stair stringer repairs such as this are risky. The patched stucco on the wall indicates how much these stairs have settled. The uneven bottom riser is a trip hazard. The top riser is higher than the other two. This creates a trip hazard. There would ideally be a landing at the top of this set of stairs. These stairs have rotted so badly, they are no longer safe. Carpet on the wood stairs holds water and promotes rot. The low railings are not effective. The mushroom growing in this stair tread indicates we have significant rot damage. This is a dangerous set of stairs. This well-worn set of stairs is no longer safe and should be rebuilt. Rot is common at the point where stair stringers rest on or near the ground. This concrete landing has settled and now poses a trip hazard due to the uneven bottom riser. This set of exterior steps and the landing above have no railing. This is a dangerous situation. The spacing of the balusters or spindles on this handrail is wide enough to allow a child to crawl through. This is not safe. The post adjacent to the siding was not secured to the siding, and we could have pushed this railing over easily. The indoor-outdoor carpeting on the deck holds water against the wood and promotes rot. This porch railing has a combination of new and old spindles. On the right you can see missing and broken spindles. Again, this is a safety issue. Wide horizontal wood surfaces are vulnerable to rot. It's common to find the rot is worst near end grains, as we see in the top of this railing. Points where railings connect to decks are also vulnerable to rot. Here we have a wood deck being built on concrete piers. The metal saddles are set in the concrete as it is curing. The short wood columns are nailed to the saddles. You can see on the right the piers are not always in ideal spots. This kind of offset is marginally acceptable, but any more would be excessive. Many decks are slightly cantilevered so that the columns are not as visible as these ones. This column appears to have no concrete pad or pier. The wood soil contact means that it may not last very long. This column is made up of two pieces of scrap wood. Obviously, this forms a weak joint. This is another column on the same deck. You can see how the column has started to settle and is no longer plumb. This pier is embedded directly in the soil. This wood column is just barely sitting on the concrete pad. This is not a stable situation. Here's another example of the same thing. This enclosed porch is resting on concrete block piers. The piers have settled and are no longer plumb. Hollow masonry units installed on their side are considerably weaker than when installed upright. When the piers are rebuilt with a proper footing, the masonry units should be upright. Here's another pier on the same structure that has the same problems. The siding is vertical cedar. This column has settled and is no longer doing its job. porch roof can be expected to drop soon. Wooden columns sitting directly on concrete will rot if water pools around the base of the column. This informal deck support is not appropriate. Evidence of rotted posts does not get much more graphic than this. The columns for this porch roof are seriously misaligned. Here we have a porch enclosure pulling away from the main structure. Can you see the opening widening near the top of the joint between the left and right parts of the home? This porch roof is pulling away from the house. Can you see the 2-inch gap between the porch roof structure and the brick wall? The separation starts at the top of the wood columns and extends to the top of the picture. Here's the other side of the same porch. The porch roof has moved at least 2 inches away from the wall. This movement is usually the result of settlement of the columns at the front of the porch. This porch has a deteriorated flat roof membrane. The plywood subflooring and the deck joists and beams are badly rotted. The plywood porch ceiling is also rotted. This is another view of the same porch roof. The heavily rotted wood was also infested with carpenter ants. This is a roof structure that supports a deck above. The beam is supported in the middle by a column and at either end by a masonry wall. At the bottom of the wood column you can see the top of a concrete pier. The pier had settled slightly, but not enough to compromise the integrity of the structure. If the porch roof starts to pull away from the house, some people believe the best solution is to apply as much roofing cement as possible. This wouldn't have been our choice. You can see the patched cracks extending down below the windows. You may also have noticed the dishing in the porch roof, indicating that the structure is not terribly strong and probably deflects more with each snow load. The front part of the roof is supported by porch columns. You can see the dishing in the roof at the bottom of the dormer. This is another shot of the same house. The masonry columns supporting the front part of the roof have settled relative to the house. Here we can see how the columns have settled and how the roof line has dropped. Notice the white trim boards at the gable end of the roof on the right. You may also have noticed that the front corner of the brick wall is moving dramatically. This shows up quite clearly in the brick at the front corner of the house on both of the front and sides. Masonry walls provide good indication of structural movement. Wood siding, on the other hand, can mask structural problems since the individual wood pieces will take up movement without creating dramatic crack patterns, as we see here. There is considerable rot in this porch roof. Again, there was significant rot and insect damage in this porch roof and house wall assembly. This low metal awning poses a serious danger to tall people. We've already talked about the poor support for columns. Here we have a deck beam that is bolted to the columns, but there's a splice in this 2-ply beam that does not occur over a column. This makes the beam considerably weaker. The carpenter's awl is a valuable tool for checking wood members for rot and insect damage. This beam is in obvious need of replacement. Here we have joists for a deck supported on joist hangers and attached to a ledger board that is bolted to the foundation wall. The spaced 2x4 decking has been laid on the diagonal. 2x4 blocking has been provided between each joist against the ledger board to support the ends of the diagonal planks. Here Here we have a wood porch floor that has been covered with green indoor-outdoor carpeting. Carpeting over deck or porch floors holds water against the wood and may lead to premature rot. We would want to get a good look at the underside of this decking. We would also criticize the porch railing. This garden-type lattice work is not very strong and presents a tempting climbing surface for young children. Here's another porch floor that has been covered with carpeting. This one is concrete, so we're not worried about wood rot here. We did criticize the absence of a railing around the porch and steps. You'll notice that there is a very little step up into the house. The roof over the porch protects the entrance area, and we can often get away with a less than 6-inch step up into the house from a front porch. We probed the base of the wood columns for rot. This extensive wood deck had no access to the area below. We documented this as a limitation to our inspection. Incidentally, those wood retaining walls will be expensive to replace when they rot. This is wood lattice skirting around a deck. Unfortunately, it extends down close to grade level and is rotting along the bottom. The downspout discharges immediately beside the foundation wall at a low point in the asphalt driveway. Will water be carried away from this corner appropriately? It's tough to tell from here. Now that we've looked at some exterior structures, we'll turn our attention to garages. This is a common garage wall and door arrangement. If you look closely at the top right corner of the garage door, you may see cracks in the wall following the mortar joints. This is very typical. The lintel for this door is deflecting slightly, and gaps have opened between the masonry and the lintel, and also between the lintel and the wood framing of the garage door. Garage doors, incidentally, should open fully so the door does not obstruct part of the opening. Garages tend to be lower quality structures than homes and tend to be less well maintained. Here's a good example of deteriorated wood siding on a garage. The unpainted gutter is mounted well below the roof shingles. There is no downspout, and the deterioration of the siding is, in part, the result of the lack of control of roof water runoff. The wood frame garage in the foreground shows considerable movement, as evidenced at the right of the overhead door. The bottom panels of the door, which are hardboard, have also buckled as a result of moisture damage. Although recently painted, the wood siding above the door shows considerable rot. While you'll want to keep garages in perspective for your clients, you do need to point out when they are in poor condition. Here's another view of the same garage. This is very typical. Here's another wood frame garage that has been straightened and stiffened with the addition of new studs and plywood gussets. At the top left corner of the door opening, you can see evidence of distress. We can't tell enough from this picture to know whether this is ongoing. Here's a masonry garage with a flat roof. It's safe to say the wood roof is in distress. Here's another shot of the same roof structure. This was a wood frame carport clad in aluminum. The roof line of the carport followed the roof line of the house. During the fire, the house roof collapsed into the house, and the carport collapsed onto the ground beside the home. This garage has a storage platform above the overhead door. The poorly built platform is sagging under the load of the storage. Wood-soil contact is a common problem with detached garages. This kind of racking is also common with detached wood frame garages. The movement can often be traced to wood-soil contact. The structural members in this wood frame garage are in distress. These garage walls are suffering advanced rot. The storage in the garage dramatically limited the inspection of this area. The door between the house and this garage has no self-closer. There is also no step up from the garage into the house. Here we have an appropriate step up from the garage into the house. There is no self-closer on this interior type door. Garage doors should be exterior type, and in many areas they need a fire rating. Here we have a step up into the home from the garage, but again we have no self-closer and an interior type door. The door opens out over the steps, which have no landing. This is not a safe arrangement. There is a step up from the garage into the house, but again we see no self-closer. The pet door compromises the fire and gas tightness of the door. We recommend that you operate all overhead garage doors. Where there is an automatic opener, we recommend that you test the opener to see if it will stop and automatically reverse when it hits an obstruction within about 2 inches of the garage floor. You'll also want to look at the tracks and rollers for overhead sectional garage doors like this. It's not unusual for tracks to be misaligned, rollers to be seized, or roller brackets to be poorly secured to doors. Here we are looking at the roller and its connection to the door. This is the tension spring on the garage door that replaces the counterweights used on old garage doors. If this spring is properly adjusted, the effort required to raise the door should be equal to the effort required to lower the door. The door should stay at the half-open position, neither falling nor rising, if the spring is properly adjusted. You can only check this if the garage door opener is disconnected. Here's an automatic garage door opener motor. Here's another view of the same door. We've had a look at garages, now let's look at exterior basement stairs. This is an exterior stairwell leading to the basement. In this case, the stairwell is partly covered by a wood deck. The railing along either side of the stairwell opening is a good detail. Here we are at the bottom of the stairwell opening. There is no railing on the stairs coming down, and although there is a drain at the base of the stairs, there is only about a 1-inch step up from the well outside into the basement floor level. Some damage to the door has been experienced, and there has been some leakage over the door sill. This sump pump was at the bottom of a set of exterior stairs. There had been chronic leakage problems into the building through the stairwell. Now we'll have a look at surface water control, including grading, gutters and downspouts, and window wells. Home inspectors check exterior grading to ensure that surface water is directed away from the building. This concrete patio will funnel water toward the house. Leakage into the basement or crawl space below the sliding door is suspected, and there may be foundation damage here. These concrete patio slabs forming a sidewalk along this concrete block foundation wall have a slope that is neither toward or away from the house. This marginal situation may or may not result in problems. These houses are reasonably close together. You can see that the ground between the homes has a low spot in the middle. This is a gentle drainage swale, encouraging water to run out into the front yard between the homes rather than against either wall. As you can see, this is new sod, and this grading arrangement was done to improve wet basement problems in both homes. The house on the right has galvanized steel downspouts going into the ground. Leakage of these downspouts at or below grade level is common. Where wet basement problems have been experienced, we usually recommend redirecting the downspouts to discharge above grade, roughly 6 feet from the house. This allows the homeowner to ensure that roof water is being directed away from the house. Here's the same situation viewed from the front of the homes looking back. As you can see, the backyard slopes down toward the houses, directing a considerable amount of surface water toward the homes. This is another shot of the backyard area. This is the same lot. You can see that the downspout has been extended to discharge well away from the house. This is a good detail. Along the bottom of the brick wall, you can see a black asphalt-based material. Recent damp-proofing efforts have been undertaken here. You can see that a garden has been created adjacent to the foundation wall, and there is a considerable depth of wood chips in the garden. This unfortunate arrangement creates a poor grading situation, even though it doesn't look bad on the surface. Gravel or wood chips will allow water to flow freely through them. Any water that gets into the garden area is going to flow quickly down and is likely to end up exerting pressure on the house foundations. The damp proofing on the side wall of this building is exposed, indicating how much the grade level has dropped since original construction. The finished grade would have been within 2 or 3 inches of the top of the damp proofing. Here again we have a concrete slab leading up to a front porch that has settled dramatically, funneling water into the foundation. Here's a new interlocking brick patio being constructed. The patio slopes dramatically away from the house, as it should. However, the new brick is flush with the bottom of the basement windows. Window wells would ideally have been provided here. What do you think about the deck and step railings? Could children fall through the spaces between these spindles? Sure they could. It's safe to describe this sidewalk as a trip hazard. Here's a fairly common situation. The gutter is plugged with twigs and leaves at the downspout connection. When you have small trees growing out of the gutters, you know they haven't been cleaned for a while. This gutter is completely rusted through. This gutter isn't rusted through, but is sagging so badly that it dumps all the water against the house in one spot. It's worse than having no gutters at all. When you hear people talk about ice dams, this is what they mean. Damage to the soffits, fascia, roof structure, and building interior are far more important than the gutter damage that might be taking place here. This is a Yankee gutter, which is, in effect, a board installed on the roof at right angles to the roof surface to divert water from running over the edge of the building. As you can see by the damage to the soffit, fascia, and siding below, it hasn't been working particularly well. There is no flashing on the plumbing stack where it comes up through the roof shingles. Do you know what the little metal tabs are sticking up out of the roof surface along the bottom edge? Those are avalanche guards, designed to keep snow and ice from falling off the roof in large chunks and perhaps injuring people below. Here's a new Yankee gutter built with copper and wood. Here's another view of the same installation. This is an integral gutter or eaves trough, again made of copper. This one is quite shallow. This gutter has a screen to help keep leaves and twigs out. These screens often fall into the gutters and actually tend to clog them. This screening looks to be in good shape, at least in this small section. Gravel from the flat roof has been collecting in the gutters. These gutters are not going to carry much water. A gravel stop at the edge of the roof would have prevented this. This is a sheet metal integral gutter which is rusted and has been tarred. You should expect leakage here. The rubberized membrane built-in gutter did not extend far enough up under the concrete roof tiles to prevent leakage. Here again we have a rubberized membrane in a built-in gutter that does not extend far enough up under the tiles. Clogged downspouts like this are very common. This is a creative arrangement. The plumbing stack is being used as a downspout. This arrangement makes both the plumbing and roof drainage system suspect. Here's a house where the downspouts are extended out at least 6 feet from the building. The general slope of the ground is down away from the home. This is a good arrangement. Here we have an aluminum downspout going into a plastic drainage piping system. This is another aluminum downspout going into a PVC drain pipe extending below grade. Here's a similar arrangement with a clay tile downspout extension. Here's another clay tile downspout extension. The performance of all these systems, once they go below grade, cannot be determined from outside the building. Here's a downspout that terminates well above a splash block. The downspout would ideally have been extended down lower, and while we are not big fans of splash blocks, this one in an asphalt driveway with a good slope is performing adequately. It's a good idea to use the concrete splash blocks even on an asphalt driveway because the downspout discharge will eventually create a depression in most driveways. Here's another aluminum downspout with a concrete splash block. Most of these blocks are only 2 to 3 feet long and do not carry water far enough away from the home. Sometimes downspouts can be complicated. Here you can see a single downspout is fed from a number of areas. It looks like the gutter on the left slopes away from rather than toward the downspout. You can see the debris that has accumulated in the gutter and the ice damming problems that have resulted. Damage to the soffits and fascia are a strong possibility here. The less of the gutter and downspout system we can see, the more nervous we are. Here we have integral gutters that we can't see at all. We can see a section of the downspout that runs on a 45-degree angle and then disappears into a section of wall. We would note these arrangements and check inside the building for evidence of leakage in these areas. The downspout was not well secured to the wall. It's pulled away from the wall and is being held in place by the overhead electric service wires. As you can see, it's not carrying any water away from the gutters. The gutter is clogged at the downspout connection anyway. Here's another downspout that won't be terribly effective. We can't resist mentioning the location of the electrical service conduit. It should be at least 3 feet away from a window. This one couldn't be much closer to the window. Here's another downspout that has been damaged about 2 feet above grade. Here's a downspout that is digging a hole beside the driveway. Here's a downspout that has been recently extended. You can see the patching on the stucco. The damage was caused by a leaking downspout. We mentioned earlier that a downspout discharging onto an asphalt driveway will eventually create a depression. You can see here that the asphalt has dropped several inches immediately below the downspout. This is so silly, we had to show it to you. This downspout is disconnected right at grade level. You can see how much damage has been caused by the water. Water from the roof has been dumped adjacent to this concrete foundation wall and retaining wall. The hydrostatic pressure and frost action has split the foundation wall at the corner and pushed the retaining wall on the left side out toward the driveway. Here's a downspout that is digging a hole in the ground beside the building. Here's a close-up of the same situation. This is a desperate effort to prevent the underground drainage piping system from becoming clogged. A screen and funnel arrangement has been put in to strain leaves and twigs out of the water. This kind of situation makes you wonder whether the house has a cistern. Cisterns are often connected to downspouts in areas where water isn't readily available or where the water quality is poor. The homeowner may be trying to keep the water entering the cistern as clean as possible. The integral gutters may or may not be working properly here. The downspout is leaking at the point where it comes through the soffit. This is damaging the windowsill and wall below. The bottom of the downspout has become disconnected and damage to the foundation is occurring here. In cold climates, it's not unusual for downspouts to freeze if they are partially clogged or if the gutter is clogged. Heating cables have been wrapped around this downspout section in an effort to prevent freeze-up. A better approach would be a maintenance program that ensures water can flow freely through the gutter and downspout system. Watch for premature roof covering deterioration when you see this arrangement. The large upper roof is drained by this downspout, which directs a large volume of water across the lower roof surface below the downspout. Premature shingle deterioration in this area is very common. The downspout used to stop about 4 feet above grade. It did considerable damage to the brick above grade. The parging didn't protect the wall much. Recently, someone has put a downspout extension on to carry the downspout down to grade level. Now the water is dumped immediately adjacent to the foundation wall at grade level. This is not a significant improvement. This downspout is severely rusted. When plants are growing out of the perimeter drainage tile riser, it's a safe bet that the tile system is clogged. Here we have a leaking downspout on an exterior wall. The electrical meter is recessed and the electrical conduit is not visible. There's an obvious electrical hazard with the concentrated volume of water from the downspout soaking this area every time it rains. Here we have a preserved wood window well along an asphalt driveway. The bottom of the window well should be 6 inches below the bottom of the window. As you can see, the bottom of the window well is almost flush with the window here. There should be a drain in the window well carrying water down to a drainage system. It's not clear that that's been done here. These galvanized steel window wells appear to be appropriately installed. Unfortunately, the grading around them is not appropriate. Water will be funneled toward the wells and can be expected to accumulate against the foundations around and below the windows. Here's a situation where a window well would have helped. The bottom of the window was flush with the driveway. To make matters worse, there's a downspout beside the window which may dump water near the window and create a depression in the asphalt. It looks as though the downspout has recently been extended. However, the damage has been done. The window frame and sill are badly rotted. Here's a galvanized steel window well with a cover designed to keep debris out of the well and prevent people from stepping into the well inadvertently. This is along the edge of a patio. The steel window well would ideally have been installed slightly higher. It is virtually flush with the grade level, and if there is any settlement, dirt may find its way into the well over the top of the galvanized steel frame. The guard on this window well prevents people from falling into the well. In some cases, basement windows provide emergency escape, to get out of a basement bedroom, for example. The guards in these cases should not prevent escape through the window well. The last thing we'll look at in this videotape is retaining walls. This is a concrete block retaining wall that failed during the Los Angeles earthquake. The wall actually only had an elevation difference of about 3 feet from side to side, but the wall extended up about 5 feet above grade level. You can see the steel reinforcing bar that was not adequate to keep the wall in place. Here's a concrete block retaining wall covered with stucco and a poured concrete cap. You can see the drain holes about every 8 feet. These 2-inch diameter drain holes are slightly smaller than would be ideal. Here we can see cracking in the stucco and concrete cap. This is an early indication that the wall is moving. You can see the concrete block below the stucco at the bottom of the picture. Here's a close-up of the movement that's beginning to take place on the retaining wall. Here is a timber retaining wall that is failing. This brick retaining wall has moved dramatically, as can be seen along the edge of the steps. Here's another masonry retaining wall that is failing. This tall concrete block retaining wall is not stable. Here's another masonry retaining wall that is moving. These walls often move slowly, but can fail suddenly, especially after a heavy rain. Saturated soil can exert significant pressure on these walls. This is a poured concrete wall that is badly deteriorated. As we look along the wall and hang a tape measure from the top edge, we can see that the wall is leaning out away from the upper side. Here's a close-up of the wall. Some of the steel reinforcing bar is visible here. This is a low, dry-laid stone retaining wall. This retaining wall on the left side of the driveway is failing and is pushing the garage wall into the garage door opening. Here's a poured concrete retaining wall on the right side of this driveway, which again is pushing the garage wall in against the garage door. You can see how the right side of the door opening is bowed near the midpoint. This retaining wall is a precast concrete system. This new retaining wall replaced the original poured-in-place concrete wall that had failed. The original retaining wall was similar to the one we looked at in the last picture. This is a timber retaining wall with tiebacks. This is a rotted timber retaining wall. This wood retaining wall is clearly in distress. This is another shot of the same retaining wall. This bowing wood retaining wall is supporting a driveway. It needs to be replaced. This brick retaining wall has failed dramatically. This poorly built retaining wall should be considered a temporary structure. That brings us to the end of our retaining wall discussion and to the end of the videotape. We hope you found this program helpful. Thanks very much for joining us. If you need information on other videotapes in this series, or more information on the complete home study system, contact Carson Dunlop at 1-800-268-7070. You can also visit our website at www.carsondunlop.com. You can also email us at info@carsondunlop.com or fax us at 416-964-0683. You may also contact one of our authorized distributors for more details. Again, thanks for watching. I'm Alan Carson.